In this podcast, Alain Stevens explores how IT teams working on COBOL systems are organized, a technical topic that is often overlooked but essential to the stability of critical infrastructure. As part of his personal 60-day challenge, focused on learning 3 major programming languages, COBOL, Python, and Java, Alain Stevens took a closer look at how teams are structured in mainframe environments. The developer analyst plays a central role, responsible for developing and maintaining programs in COBOL and JCL, while the architect oversees the overall system design and coherence. Other key roles support the structure. Technical relays assist less experienced developers, project managers coordinate with business needs, team leads manage resources, and production schedulers ensure the smooth execution of nightly batch processes. This hierarchical and specialized organization helps ensure the reliability and longevity of systems used in banking, insurance, and public institutions. The podcast offers a clear and accessible overview of these functions, aimed at newcomers and curious minds. Alain Stevens also encourages professionals to share feedback or corrections to help enrich this initial overview of the COBOL ecosystem.
C'est quand même étonnant, hein? Un langage informatique.
How are IT teams working on COBOL systems organized? As part of his personal COBOL plus Python plus Java 60-day challenge, Alain Stevens set out to better understand and structure the key roles commonly found in mainframe environments: developer analyst, architect, relay expert, project manager, batch operator. Each role plays a vital part in ensuring the stability and maintenance of critical systems. He shared a summary article on LinkedIn, both educational and open to discussion. It's a starting point, meant to be enriched with your feedback, insights, or corrections. Your comments are welcome to help improve this perspective on the COBOL ecosystem. Visit the Pacta Cobol websites for more information.
Okay, let's unpack this. Forget everything you might think you know about old tech. Seriously. Imagine a programming language, right? Premiered the same year Hawaii became a state. 1959.
Wow, 1959, that's quite a while ago.
It is, and yet it's still this invisible engine running critical systems. We're talking trillions of dollars daily.
Trillions.
In major banks, insurance companies, government agencies. It's everywhere, just hidden.
And you're talking about COBOL, aren't you? It's fascinating because it's not a relic, it's really a cornerstone.
Exactly, that's what jumped out from the sources you shared.
Its continued role is, well, genuinely surprising.
It really is, and that unexpected relevance, that's our jumping off point today. This deep dive is all about figuring out why. Why is COBOL still so vital?
And crucially, who are the people keeping these huge essential systems running? What do those teams actually look like?
Right, so our mission, using the material you provided as our guide, is to sort of pull back the curtain.
Yeah, uncover the key roles, the specific skills you absolutely need.
And how people are even getting into this field now. It seems so specialized.
It does, and these sources give us a pretty good map for exploring that.
Think of them as the blueprint, yeah. We're looking at a part of our infrastructure most people just never see or think about.
Okay, so where do we start? The big why.
Let's do it. Why is COBOL still here, doing all the heavy lifting? The sources seem pretty clear on this.
They are. They point to a few core reasons. It's heavy use in banking, insurance, the public sector. It's not random.
No.
No. It's because these systems, built decades ago, are incredibly stable, really reliable. They were designed for, massive transaction volumes.
The kind of scale you absolutely need when serious money or data is involved.
Exactly. And then there's this huge factor the sources call legacy and complexity.
Yeah. That sounds significant.
It is. We're talking code bases with literally decades, 40, 50, sometimes more years of business logic baked in, regulations, custom tweaks.
Wow. So decades of evolution captured in code, like a massive, intricate puzzle.
A very intricate puzzle.
Right.
And trying to just rip it out and replace it.
Forget it.
Pretty much. The sources stress the cost is often prohibitive, sky high. And the risk.
Right. The risk of breaking something essential must be enormous.
Exactly. Disrupting banking or insurance systems, it's often just too dangerous. So maintaining and carefully evolving what works is usually cheaper and, frankly, safer.
So it's like it works, it's stable, changing it is terrifying and costs a fortune. Makes sense.
It does. Plus, performance. For certain things, COBOL is still incredibly efficient. especially batch processing.
Batch processing. Explain that a bit.
Sure, these are the huge background jobs that run, often overnight, processing millions of transactions, calculating interest, generating statements, processing claims.
The massive number crunching task.
Exactly. They need speed and the ability to handle enormous amounts of data at once. Cobol was literally built for that kind of thing.
Okay, so essential systems, massive complexity, super stable, high performance for key tasks, all relying on Cobol. That immediately tells you, okay, you need people who understand this stuff. There has to be a demand for this specific skill set.
There absolutely is. And the sources lay out what those skills are. It's not just knowing Cobol itself, though obviously that's key.
Right.
You also need SQL for the databases, and critically, JCL, job control language.
JCL. That sounds very mainframe specific, doesn't it? How's that different from, say, writing a script today?
It's fundamentally different, yeah. Modern scripts often tell an application what to do. JCL tells the mainframe operating system how to run your program.
Okay. Resource allocation, file handling,
Yeah.
that sort of thing.
Exactly. Input, output, managing system resources. It's a specific command language for that whole architecture. You also often need some UNIX familiarity as it runs alongside, and you definitely need to know the 3270 terminal environment.
The famous black screen. Or green screen, maybe.
That's the one. The sources call it emblematic. Working with that means understanding a different way of interacting with the system. It's often record-based, not a continuous stream like we're used to.
So it's more than just learning commands. It's learning a whole different way of thinking about how computers work.
That's a great way to put it. It's a different paradigm, and you're usually not building brand new things from scratch.
Right. You're working with code that's been around for ages.
Precisely. So a huge skill is just being able to read, understand, and safely change these enormous, complex, existing programs. Part detective, part surgeon,
Detective and surgeon, I like that. So if the skills are so unique and tied to this older environment, where do the new people come from? How do you get into this world?
That's a key question the sources address. They bring up specific training pathways like Alain Stevens and the Pacta Cobol training program.
Pacta Cobol. So these are set up specifically to fill that need.
Exactly. They're positioned as a direct response to that market demand for skilled Cobol pros. A vital bridge, really.
Not just an academic thing, but practical job training.
Very much so. The sources say they're geared towards beginners, taking a really accessible, hands-on approach. The goal is clearly stated. Help people learn these skills effectively, open up new career options in this area.
And presumably, they cover those specific things we just talked about, Cobol, JCL, SQL, the terminal.
They do. The aim is a solid foundation. Cobol fundamentals, navigating the mainframe world, JCL, SQL, 3270, UNIX interfaces, and getting those basic analysis skills for dealing with existing code.
I also saw that Alain Stevens did this, like 60-day challenge, exploring Cobol alongside Python and Java.
Yeah, that's interesting, isn't it? It kind of underscores the idea of bridging the old and new.
Right, it's not about being stuck in the past.
Exactly. It highlights that working with Cobol today often involves connecting these powerful back-end systems to modern front ends or services. So training like Pacta's is presented as a really valuable way to get integrated into these essential teams and build a career.
Okay, that perspective shift is important. It's not just old tech. It's a critical piece of a bigger evolving system. So let's say you get the skills, you get trained up. What kind of team do you actually join? What's the structure like?
The sources paint a pretty clear picture here. These teams are usually well-structured, often following a classic IT model. You typically have what's called a maîtrise d'œuvre, or MOE. Think of that as the technical side development, project execution.
Okay, the MOE. Who do they work for?
They work for the maîtrise d'ouvrage, the MOA.
MOA.
Yeah.
That's the business side.
Exactly. The MOA represents the business unit, the client. They define what needs to be done, the requirements. The MOE figures out how to build or change the system to meet those needs.
Got it. Business asks what. IT figures out how. So who's actually in the MOE doing the technical work?
Well, right at the core, you have the analyst developer. The name says it all, really. They analyze existing code, develop new stuff, modify programs, fix bugs, do testing.
The other one's deep in the Cobol, the JCL, the 3270 screen.
Right here. That's them. And the sources mention this is often the entry point for people coming into the field.
Makes sense. The hands-on coding role. Who do they work closely with?
Well, constantly with the MOA, the business side. The MOA translates those business needs into functional requirements. They're the voice of the user.
But they don't code themselves, right?
Correct. The sources are explicit. They do not program. Their expertise is the business domain, banking rules, insurance policies, whatever it is. They define the need and check if the tech solution actually meets it.
Okay, clear separation. What about support for the developers, like getting things ready?
That's often the preparator or preparer. They work a bit upstream.
Upstream.
Yeah, preparing things like test data, setting up test environments, defining test cases. They help the analyst developers be more effective by making sure they have what they need to build and test things properly.
So they grease the wheels for development and testing.
Exactly. And they sometimes link business needs to technical tasks and often have strong ties to the operations or production teams, especially for those big bash jobs.
Okay, what about technical leadership or guidance within the team? Making sure things are done well.
For that, you often find a relay, which means relay, or sometimes just called an expert.
A relay, what do they relay?
Technical information, mainly. They act as an interface, maybe between the developers and the high-level architects. They gather feedback, coordinate technical changes, and act as a sort of consultant for less experienced devs.
Like a go-to technical person.
Precisely. And they help enforce good practices, like the sources mention avoiding go-to statements in COBOL. The relay helps keep the code clean and maintainable, preventing that spaghetti code nightmare.
The technical conscience of the team. And above the relay, is there an architect?
Yes, the architect. This is a more senior, big-picture role.
Defining the overall structure.
Exactly. Defining the architecture, setting technical standards, planning long-term strategic changes to the system. They're focused on consistency, performance, and avoiding what the sources nicely call IT disorder.
IT disorder, love that. Keeping it from becoming a total mess over time.
That's the goal.
So you've got the coders, the business link, the preparers, the technical guides, the architects. How is it all managed? Who keeps it organized?
That falls to the management structure within the MOE. First, you usually have the chef de projet, the project manager.
Standard role, right?
Yeah.
Coordinating the developers.
Yep. Coordinating the analyst developers, liaising with the MOA, organizing deliverables, planning tasks and schedules. They're responsible for getting a specific project done.
Keeping that one train on its track.
Exactly. Then, often supervising several project managers or maybe groups of developers directly, is the chef de keep, the team leader.
So managing multiple projects or a larger team.
Right. They manage resources, coordinate across different project activities, and ensure overall technical quality and that the right methodologies are being followed within their group.
Stepping up a level. And is there a level above that mentioned?
Yes, the chef de domain, the domain manager. This role has oversight of a much broader area, either functional or technical.
Like all the applications for checking accounts or something.
Precisely. Or maybe all the systems for a whole line of insurance. They ensure the overall consistency, strategy, and performance for their entire application domain.
Wow, okay. That paints a really clear picture. It's a very structured environment, isn't it?
It really is. Highly structured, hierarchical.
And it feels like it needs to be, given the complexity and the importance of these systems.
Yeah.
Clear roles, clear responsibilities.
Absolutely. The sources suggest this structure is typical for these large legacy COBOL setups. It blends the technical skills, the business knowledge, and the management oversight effectively.
And it also shows clear career paths, doesn't it?
It really does. An analyst developer isn't stuck there. They can grow into a relay, an architect, or move into management, project manager, team leader, maybe even domain manager eventually.
So it's not just a job, it's a potential career track with real progression. Okay, stepping back then, how does this whole ecosystem, all these defined roles, actually work together day to day?
Well, they collaborate within that MOE framework we talked about. The MOA comes with a need. The MOE team, led by the various managers, guided by architects and relays, supported by preparers, figures out how to meet it.
And the analyst developers do the actual work.
They do the coding, the testing, the fixing. It's this continuous cycle, really. Maintaining the systems, evolving them as business needs change, and just keeping these critical operations running smoothly.
It sounds like a very integrated machine, highly tuned, built over decades to handle this specific kind of complexity.
That's a good way to describe it. Each part, each role, from the preparer setting up tests to the domain manager looking at the long-term strategy, is pretty vital.
Okay, so let's try and wrap this up. To summarize our deep dive here, COBOL. Still incredibly relevant, surprisingly so, right?
Definitely. Powering critical systems because it's stable, the existing code bases are enormous, and replacing them is just too costly and risky.
And we nailed down the specific skills needed? COBOL, sure, but also JCL, SQL, the 3270 environment, understanding that whole mainframe world.
And we saw how specific training, like Pacta's programs championed by Alain Stevens, provides a real pathway for people to get those skills and enter this field.
Yeah, crucial bridge.
Yeah.
Then we deconstructed the teams themselves, that detailed structure.
Right. The analyst developer at the core, the MOA representing business, the support from preparers, technical guidance from relays and architects, and the management layers project team and domain managers.
All working together in that MOE structure to keep these vital systems going. Understanding the structure, understanding the training, it really shows how specialized but essential this part of IT is.
It really does. It's a unique but incredibly important corner of the tech world.
So here's a final thought to leave you with. Considering everything we've discussed, this deep reliance on COBOL systems, the established ways of working, the sheer difficulty of replacing them, how does that reality shape technological change in huge sectors like banking or insurance? Does it create a kind of tension, between the constant push for the newest digital innovation and the absolute need for rock-solid stability and continuity in these core systems?
Yeah.
That feels like a balancing act worth thinking about.